So what are some of the hazards that could happen when lifting this table?
Okay, if someone is passing by and if the person is blind, he cannot see or make sure that the corner is very sharp and it might hurt that person. So we need to insert something there to make sure the person is not getting hurt.
Perfect. Excellent. What's something else that could
Yeah,
be
when
hazardous?
something very hard or very weight items are there on this, we cannot push it easily. We need more strength and we need to put more pressure, and this will affect our back, our muscles and also our shoulders. This is also harmful for us.
Yes. So what can we do to minimize the
I
back
need
pain?
support from anybody else. I need to take someone who can help me out with that.
Excellent. Excellent. And then we could also practice good lifting techniques as well.
Yeah, ma'am.
And what's a good lifting technique? We can bend our knees, right?
No, we can take it from the down and
Yes.
take more help and get it done. It's not easy for a person to do.
Sometimes we just need more help, right? And
Exactly.
just getting a few more people to help us if it's heavy. Anything else?
That's all, ma'am. Like, it may hurt any people if they're not having an idea about the sharpness. And when you're taking this table down, you might need one more person next to you who can hold up that, because when it's sliding, it may just slide away. There are chances that you may also slip and fall down. So we need to be very careful about all these things mentioned.
Perfect. Thank you.
Welcome.
Thank you. So Keisha, hold on. I have a little gift for Keisha. Keisha. So thank you so much for giving us a hand. I appreciate it. And so, whoops, we lost our. Okay. Well, you saw the form up there. And so what we would do is we went through the whole exercise of what are the hazards. We identified the hazards. We had identified how do we minimize those hazards. And then what we would do on the form that I had up there is we would list every single hazard, 1, 2, 3, 4. And then we would go across and then we would say, okay, to minimize that hazard, I'm going to do this for this one. And we would go 1, 2, 3, 4. And then after that, we would then start putting together our audit plan. And just as Steve said, we will go and look at the process and observe somebody lifting that table and see if they actually did the process like we said, and make sure they're being safe. Okay? Does that make any sense? All right, super. Yeah, here we go. Here we go. So we have the job step, all right? What are some of the hazards? So I lift. I could have sharp corners. I could hurt my back. And then what are the controls? I'm going to make sure if it's sharp, I'm going to minimize the sharp edges. Maybe put a cloth over it, maybe put some tape. For hurting my back, I may ask for help. Okay? Use proper lifting techniques. And then who will make sure this happens? Okay? It might be a supervisor. It might be the safety professional. And so then you go through every single step and do all of this. And then voila, you got your audit document to make sure that you're auditing the process. So if you're happen to be lifting this table on a regular basis, you can make sure that are doing it safely. Okay? All right. Maybe we do this. There we go. All right. So reporting and documentation. We put these. A lot of times we'll have these job hazard analysis in a book right next to the workstation, or we post them right on the machine. I like it a lot when they actually post them on the machine. That way, anybody that comes and uses that machine really understands what the hazards are for that machine or for that job, and it's very clear, and it helps from a training perspective. And then there could also be some corrective action plans. Maybe there's a process where we need to minimize that hazard, and it's going to take a few days, a few weeks to actually implement the solution. And so maybe we need to have corrective action plans to show everyone that, yes, we know this is a hazard right now, but this is what we're doing to make sure that it's not a hazard in the future. And then follow-up procedures. And then continuous improvement. As with everything, you don't just post it on the machine and forget about it. Okay? You need to refresh it every now and then. Things change. You know, maybe somebody came into that job and figured out a new way to make it more safe. And so there's always this continuous improvement. And so you want to make sure you're updating your job safety analysis on a regular basis. And, you know, every 3 years is a good rule of thumb, but sometimes every year it needs to happen. And so it all depends on what your area and what you're trying to do. And then the audit strategy, and Steve talked a lot about that before me, so I won't go into that. All right, and that was it. All right, thank you so much.
Thank you, Lois. Okay, now I talked to RV students. Now let me talk to AMC students. See who can answer my questions. Okay, is there anyone who would like to be questioned? Anyone want to raise? And otherwise I will make a selection. I can pick somebody. No one wants to raise the hands? I want to get any of these. Okay, let me ask someone here. Okay, let me ask you.
Ask a question.
Ask a question. Yes. You are AMC, right? Yeah, please stand. I will ask a question. Mike Kodayappa. Not yet. Not yet.
They need
Not
the mic.
yet. Mike. Quick.
They need the mic.
Okay. This is the question. Job hazard analysis of moving a bench or a table. So, how do you do it? No. Hey, no. Yeah.
Taking someone for help, sir.
So what? Why do you want another help?
Because I don't have any knowledge or I don't have any idea about that.
Yeah. So don't help him, please. Okay.
I use some ideas
Okay.
to moving using some rotating like
Okay.
wheels will be there also. To
Okay.
That help I will take, sir, to move that wheel.
So you want to move it.
Moving.
So what do you need?
Other support I want, sir. Like it's
Okay.
lifting or not. I mean, I am not lifting. I use the support.
Okay. So you seek support.
Yes.
Okay. What is the next one that you need to do?
What-
What else you need to do?
What's the help? What's the help to moving the bench? Why we need to lift the bench?
Okay. Then?
Then I use this precaution. Why we are lifting? Then what's the help to others? We can analyze and we can move the
Good.
things.
Good. You have some concepts, may not be all of them, so I would like to reward you with this. Thank you. Okay, just one more question for the RV women students. So, question to ask? Me or the speaker? Okay. Lois, you have a question to answer. Lois. Yes.
Hello, ma'am. So you mentioned about environmental hazard.
So if you have an environmental hazard, so let's just use temperature, okay? So if we have a high temperature in an area and we want to protect the people from that high temperature, then we do the same process. So the temperature goes up and we say, okay, what are the different hazards that could happen? And then how can I minimize them? Can I put a fan in that area? Can I put that person in a cool protective suit or something?
Are you talking global? Global.
Thank you, Lois.
She's talking about global climate change.
Oh, global change?
Yeah.
Like global climate change?
Yes.
Oh, okay. Well, that's a way big problem. I'm talking small problem. That's big problem.
I think it will be a totally different arena where that question can be asked. May not be in the same format Lois made the presentation. Yeah. So it's a good question, but may not be the topic that involved now. But I still recognize you for something because you asked a question that we did not answer. Richard, can you please give her a momentum? Yeah. Which one you like? Okay, thank you very much. Thank you, Richard. Thank you. Next presentation, please. Before you go, I just take 1 minute to introduce my friend, good friend from BIT, a professor in civil engineering, and he is here to see how it is going. Thank you.
Thank you, Lois Brandon ma'am. Now I request our ex-principal, Dr. Malaysia sir, who is currently serving as professor in EC department, to address the next speaker of the day.
Thank you very much, madam, for that exciting and wonderful session. Good afternoon, everybody. I deemed it as a privilege to introduce the dignitary and the speaker of next session, Mr. Robert A. West. West has been president of R.A. West Associates, an engineering and consulting services firm focused on the assessment, design and management of property-related environmental issues. Mr. West has over 43 years of experience in managing, operating and developing engineering, consulting and cleanup contracting business for several national and international corporations. Mr. West received his bachelor degree in chemistry from the University of Cincinnati, studied graduate level analytical chemistry at Radford University. Mr. West received his certification in 1992. He is also a fellow and distinguished diplomat of the Institute of Hazardous Materials Management. Since 1994, he occupied and served various positions like chairman, vice chairman, board of member, technical guide in more than 13 organizations. I offer him a warm and hearty welcome for the next session. Thank you.
Good afternoon. While we get set up, I just want to introduce some ideas and get some feedback from you. This is really an interactive discussion. We're looking for questions from you as well. But how many in the audience are involved in biology? We have a few. How many are chemists? We have one or two. How many are civil engineers? How many are other engineering disciplines? Okay, very good. Thank you. Gives me an idea of what I might be expecting in terms of, thank you, in terms of questions. Very good. So today's topic is facility assessment and investigation. We're talking about properties that have contamination issues. It might be looking to be repurposed or under a regulatory format requiring cleanup. So we're going to talk about how you set up a program to assess what contaminants are there, what receptors are there, and what the resulting cleanup might look like. But we have participants in this process we have to be aware of. And so they bring forces to that particular design step that we need to consider as a consultant or as an employee of an organization where you're doing the cleanup. Essentially, owners have that total responsibility of making sure things get cleaned up, but they also carry the burden of financing that process. So not only is the remediation costly, the assessment to get to that point of deciding which one we're going to go with, which method we're going to use, is also costly. So that's one element. Then we have regulators. We have Karnataka State that may be saying, you have to clean this up, and you have to do it in 2 years. That time frame becomes critical, because now you have to do an assessment of the property in order to get to the design, in order to implement the remediation. And that means allocating time, allocating the amount of resources that you have to come to the conclusion that you need to in order to go forward with that remediation. In addition, you're going to have outside forces, I'll just call them generically, the public in general, that they can't live with the resulting contamination. Maybe their water well is being impacted. Maybe the air source is being impacted. Excuse me? Lost me. Can we get me back? Perfect, thank you. So those outside forces, such as Bhopal, someone mentioned Bhopal before, became significant, and the result was that that plant no longer operates. We're looking at same kinds of forces that create motivating timeframes in which things have to be completed. So, facility assessment and investigation. Did we wake up? Let me see if we can go forward here. Okay. So we're going to describe the goals. What are the goals associated with doing the assessment? And one of the approaches is called the triad approach. It's really a process of doing iterative steps to create a resulting improved process. We're going to talk about data quality objectives process, the data quality that you need as opposed to that you might want to be very definitive about. Then there's, at the end of the presentation, there's a visual sampling plan. I'll hit that very shortly. This presentation actually has a relatively coarse review of those 7 steps involved in assessing a property, but it also has a very detailed secondary step and then a very, very much detailed step after that. I'm going to see how far we get. We'll do the first 15 or 20 slides and get to a point where you understand the concepts, and then we may go into specific things in detail if I see an interest here. Sampling and analysis plans, one of my favorite topics. Sampling and analysis plans simply tell us what it is that we're going to do in order to characterize the site. But in order to get to that point, you need to understand what the problem is. You got to be able to state the issue. What is it that we're looking to quantify? And it might be that your issue is within the first 2 feet of an aquatic system. Say you're in a swamp, and you worry about the nematodes in the swamp, but the regulatory factors tell you, I only have to worry about 2 feet of that swamp. This is a case that I just finished doing. You don't need to know what's deeper. You only need to know what's at top. Don't spend the client's money to develop a plan that mitigates the entire swamp, and you don't have to do that. So we're going to develop an approach for collection of data based on those factors. We're going to see what information we really need, like I just mentioned. There are constraints, obviously regulatory constraints, could be constraints mechanically, like you have foundations or you have dispersed kind of utilities or other improvements you have to be aware of and can't move. What are the methods that you're going to use? There are many standard methods for sampling. One of them that's commonly used is called American Society of Testing Materials. I write some of those standards myself. That particular organization puts out a whole raft of understandings that allow us to design a particular method for cleaning up or for characterizing that cleanup. So, what type of system are we going to do the sampling on? This may be dictated by how definitive we have to be. If we have a very toxic substance at low concentrations, we may need to have a very low confidence interval. We may need to understand very clearly what it is that we have in there specifically, because that threshold between what's clean and what's not clean is not very big. So random sampling is one method. It basically does not rely on understanding subunits, whether it's stratification of subunit or distribution over an area. But that kind of sampling is one very viable method. Stratified sampling is another, and then a combination is the third. So this slide we're going to quickly run through because the triad approach is something that most people focus on in the end. Why is it not going forward? Okay. So, what are the principles that we're looking to implement here in the management side? I found out. I just moved it the wrong way. Thank you. So, the principles we're looking for. Thank you. We're looking to plan, as we've just discussed. we're doing a preliminary assessment, which might be an investigation that's really limited by virtue of visual inspection, historical records research, coming up with some kind of understanding of what happened at the plant or at the facility you're looking at. But you need to set goals in that process as well. So you're taking into account all the things I just mentioned to set the goals for the strategy to be developed. Then we're going to set out a model. That model will be designed based on the configuration of the property for the purposes of sampling a contaminant distribution. And that conceptual model is going to go through iterative processes of becoming refined in what we see going on here. And the goal and the endpoints are going to be discussed at that step. Then we're going to develop the actual process. We're going to, after we've done the conceptual model, we've done the check on the conceptual model, and we come to the endpoints, we're going to modify that model in that iterative process. This is the triad approach, an iterative approach. We're looking to do systematic planning of the project. We're going to dynamically modify that as we learn things going around. We're going to do real-time measurements to refine it. We're going to come back and do this again. So, there's three basic elements. We're going to make sure our data is of a quality that we can afford, that we can refine, and that we can actually produce a remediation conclusion that's defendable to the agencies. We translate these goals into objectives. Identify the information gaps, because there will be. When you're looking for a particular contaminant or another area, each time you define that area in your assessment, it will change slightly. The process takes years sometimes, at least months, and you need to make sure that plume is not moving farther or becoming outside of what you decided the conceptual model should be. So what do we need? What are the things that are important in doing this work? Well, we need a work plan, but that just simply sets the broad scope of things and the goals involved. A sampling plan we mentioned. Quality assurance. We can't miss that. That tells us that what we've collected in terms of samples and the resulting data is defendable. And then a health and safety plan, the last thing. That keeps our workers safe when we're out in the field. So preliminary assessment-wise, we're going to identify the problem, we're going to set the goals, we'll develop a strategy, and then we'll implement that strategy. But we're probably going to revisit this thing a few times. So here's sort of a timeline, if you will, going from top to bottom. We need to determine with the owner what is going to be done with the property, what's his goal. Sometimes, when you have a groundwater issue, and you want to remediate, the least costly method and the most provable method is just to do what's called M&A, the actual natural attenuation of a contaminant over time by virtue of the actions of the aquifer or the subsurface beta. So regulators are sometimes hesitant to buy into that, so that requires quite a bit of data to make sure you're on the right trend to get to an endpoint at some time. But if the owner plans to keep that property for years and doesn't intend to move from the site, he might find agreement with the DEP or your agency, whatever the regulatory agency is, to do this kind of work, but you have to prove that you can get it done. So we set the goals, we come down to the approaches and decide on the tools that we're going to use. How do you develop a sampling plan then? What data quality objectives are our most important step. The process of designing the collection of the data and the number of samples, the locations, why and how, based on the distribution of the contaminants and the analysis that you need to meet those objectives. So it's 7 steps, and this we're getting into the core of what I'd like to speak about today. The 7 steps in developing a sampling plan, the systematic planning step, the iterative process of going back and refining that and designing the ultimate outcome based on the alternatives available. So you state the problem. Sometimes that's not easy to do. Sometimes when you look at a site and you think, well, this is all a surface discharge of metals, if distributed through a water system, it's settled into a sediment area, and I'm just going to clean up that sediment area, that's fine. That's where we're headed. Well, in fact, a little thing called weather gets in the way. Hurricanes, heavy rains, fires, runoff issues from other properties, those all come to a point where they can change the distribution of what looks to be an obvious surface discharge into a subsurface contamination issue based on folding in sediments, stream bed activity. Those kinds of things need to be considered. Second step, you need to decide what it is that's the potential actions you're thinking about doing. If it's that surface discharge and you've got an aqua it's contained, and you're just going to dig it up and take it away, that's great. If you're going to take time to do an M&A or actually going to do a risk-based analysis and come up with the resulting remediation step that you can prove to your agency is actually going to work, that may take a little more time. So we identify the inputs of information. That goes back to the initial discussion that we had about elements, people, entities involved in the process. Make sure we've got a little buy-in going on. Within the property, there will be boundaries that you think certain contaminants are confined to, essentially. And when you design your sampling system, it needs to take into account at least some perimeter of that particular boundary set. You have metals over here, you had organic discharges over here, and you came up with a plan that simply didn't look at the intersection of the two or didn't consider that area of the intersection is actually going to be a resulting problem for you down the road. Develop a decision-making rule. This means simply prioritizing those things within one decision that are more important to you and therefore require a better understanding. And those that are not fall down lower, and you don't look to those to drive your decision-making for the actual remediation process. Here's the devil in the details. Being able to understand what errors you can live with. What is it in the data set that it's not all that important to you? You need to know, but you don't need to know down to the nth degree exactly what it is that's in that location. Those kinds of errors need to be taken into account. That's part of the process. And then you optimize the design. Now we're going to go into a little more detail based on these steps of data quality objectives. We need to clearly define the problem. That's the upfront issue. Probably the most important step you'll ever take in setting up the remediation. You need to take the activities that you think you need to do and concisely state them. Put them into a document so you understand. You need to look at what it is that's going to come out of that decision-making process, who on the team is going to help you make that decision. Then you give us a summary of the resources you have, financially, mechanically, any restrictions you have, the time and budget constraints that are associated with it. So history of the site is probably the most important first step. If you have articles from local publications, you have history of the operating facility that was there. In one case that I had, it was a power plant. The power plant turned into a facility that actually rented out properties to research entities. So they had a whole series of chemicals, and then followed by a production of metal plating. So what are the contaminants of concern? You decide based on those things that you've collected in the history where you want to go to look for the contaminants and the configuration of the site itself. So what are the likely pathways to receptors? That's what drives regulatory decision making. If you have a stream bed in it, it's pulling the contaminants away from the discharge source and putting it into an aquatic situation. Receptors could easily be fish, could be any kind of plant life or cell life on the shores of the stream or in the areas that are wet or damp around the stream. What's sensitive populations? What's the actual population that's most likely to be affected by the contaminants? Risk assessments or risk analyses or risk-based standards are based on the fish, animal, or insect the most susceptible to being affected by the contaminant that you decide is there. Do interviews. Those interviews, the observations, the news articles, those are all things that we talked about before. Historical photos. If you have fire maps of what the area looked like, or you have maybe satellite views of an area that you're involved with, you'll get a better idea of what's going on. And then the regulatory history. What is it the state's been saying to you about what's happening there? So this set of preliminary questions is the same as if you were doing an environmental impact study, or the same if you were doing a financial document for a bank to understand what's at the site. You're basically asking, what is it that's there that can be discharge affected or otherwise need to be cleaned up? And then you develop your conceptual model. So the conceptual model takes the synthesis of all these things that we've considered and puts it into sort of a map. Here is a very simple conceptual model. Landfill over here with the drums, discharges into the subsurface soils, is picked up by a well, and the persons that living in that home become affected by whatever that discharge was. This is a more complex situation where you have intervening clay layers or layers of water, either vedostone or groundwater and bedrock, that can receive these kinds of contaminants. Each time you pass through a subsurface phase, you're probably going to have another sampling design. Oftentimes sites that even just handle water, just consider the water, have a vedostone set of samples, groundwater set of samples, and a bedrock set of samples. There we go. Required actions, principal questions, the alternative actions. Now we're talking about what it is that we think we need to do to fix this site. The output steps is the decisions to be resolved. You make a list of those. You understand the outcomes that might come from those and tell your client it's going to be expensive. That's ultimately what you have to do. Examples of possible decisions: contamination is greater than background. There's a threat to groundwater. You know that you have a contaminant you need to characterize. Maybe it has been already. Contaminant distribution is maybe the water flowing through the area, and you have to assess that. And maybe natural attenuation is occurring already. But if it is, you need to understand the rate at which it's happening, because that's what the regulators are going to be interested in. People are exposed to contaminants, a very important step. What are the pathways for that? Examples of possible decisions. This contaminant levels are greater than the action level. The cost-effective remediation options are X, Y, and Z. it's possible to apply innovative remedial approaches. Which ones? Which ones might work? Institutional controls, can you just leave it there and maybe make the groundwater subject to a CEA, or make the soil and that above ground use something very restricted? So do you want to go the route of a risk-based entity, a remediation entity? That's a big step. Most owners realize it's going to cost a fair amount of money to make that decision. It also leads to long-term monitoring, which is costly. 10 years, 30 years sometimes. Identifying the inputs require action and the outputs from this step. So here goes a little dollar-related analysis. So the triad combines the field sampling, the fire quality lab analyses, the balance of the balanced representativeness with uncertainty. So the top line is sort of what you don't want to do. Spend a whole bunch of money up front to design a remediation that is not complete. The steps we're talking about remove that possibility from happening. That's the intent here. Lower down, you see, we need to have a complete characterization, but it's going to cost some money, and we design a remediation that's actually going to fix the problem. So it leads to a lower project uncertainty. Define the boundaries is a step. Here's an idea of boundaries. Top layer of the soil, bottom layer of the soil. Maybe you have two contaminants, one that you can say is only discharged in this area, one that was discharged in this area, and you can start limiting down where you need to take samples. This decision-making process to get down to those units, those subunits, that's critical in the design process. Decision-making rules, you follow those till the end, essentially. So here's an example. You have some PCE and a concentration that's downgraded and before the well system that you're looking at, and the area you're looking at, and as well as upgrading. You need to do further assessment. Sometimes you have an off-site source. If you have an off-site source, that may be somebody else's problem and not yours. If the mean level of arsenic is high, and this is an older slide, so one part per billion used to be what the U.S. used now in certain states where we know there's naturally occurring arsenic, where we're going to say that maybe 5, 6, 7 parts per billion. But can it be left in the soil? We have to decide. What's the error tolerance? Can a client live with something that he might have to work on for a while longer, or does he want to have it done now? And if so, is the error tolerance associated with each one of those scenarios well defined? Is it in your plan? I think I'll slide through some of these things. Now we're getting down to the end. Data quality is an entire separate process here. The decision performance diagram for this kind of data quality analysis includes looking at the parameters that will exceed and those that will not exceed a given regulatory standard. So, sampling analysis plan, you got to defend this way you've driven it, how you laid out the actual sample points. And it's one of the ways it's done is through software. A visual sampling plan in software can give you all those statistics that you really need to understand where the wells go, inside the building, outside the building. You input it, you let it come up with your graphs that decide how tolerance limits might be set. And the result is that you have a remediation that's designed with an actionable level and an area in which you don't really have to do much. Here's some of the references, and I'll leave that to questions. I think we made it.
Good afternoon, sir. So my question is, which statistical technique is better, such as student T distribution or macro chain technique?
So repeat one more time. I didn't quite catch all of it.
Which statistical technique is better, such as student T distribution technique or macro chain technique?
So I'm still not catching it, so I apologize. I'm a little hard of hearing.
Which statistical method is better?
Which method is better?
Statistical method.
Most of the statistical methods that are acceptable today, just lost me something there, are based on the confidence interval you're really looking for. That approach is very simple, but random versus a means of combining random sampling with statistical sampling is probably a better way to go.
Is the question answered? What is it? Is the question answered?
Yes.
Okay. So, Richard, please give us a memento if you have. Okay. Come here quickly. Yes. Okay. Yeah. Thank you. Thank you. Thank you. Okay. Oh, okay.
So my name is Purti from Civil.
Yes. Thank you very much.
Third
Thank
year.
you. Are there any other colleges representing? We got RV College, we got AMC. Any other engineering colleges represented here? No? I thought there were other engineering colleges represented here. Okay, if not, I will ask a question to the lady up front with yes. I have a question for you. What is sample analysis plan? The speaker talked about in detail. So, do you remember anything that the speaker said? You don't? Okay. Yeah, please sit down. Anyone else? Sample analysis plan. Okay. Let me ask this gentleman, second one. Yes. Please stand. Please stand quickly. Okay. What is sample analysis plan that the speaker defined? Kenapa? Do you remember anything? Did he talk about it? Okay. The second person did not make it through. So let me go to the backbenchers. Okay, the second person from the last. please stand. What is sample analysis plan? Then you can't go to the lunch. There will be no lunch for you. Huh? Okay, anyone in this group? Hold on, don't go. Don't go. I'm asking a question. Okay, anyone in this section can tell me what is sample analysis plan? Okay, come on. Oh, sorry. He raised his hand first.
Set of protocols and monitoring systems used to use for contaminated particles or contaminated water or like anything contaminated to clean it and recycle it to save the environment from contaminated and hazardous materials.
Thank you very much. Richard or Kendra, do you have any mementos to give quickly? If anybody has any memento for the US delegate, yes. Okay, you answered the question, if not full, but it is relevant to the sample analysis plan. Thank you. Thank you very much.
I want to recognize the presence of head of the Tegutech Israeli company here. I am very proud that